So guys, we are starting with exercise 9B of complex numbers. Okay. Now, before I start up this particular exercise, I would like to clarify a few things. Okay. So the first case is if something like 7 upon I is there as an example. So whenever there is a single I, multiply and divide with I. So this will be 7I upon I square, 7I upon minus 1. So the answer is minus 7I. Okay. If it is 7 upon minus I, 7 upon minus I into I into I. So 7I upon minus I square, 7I upon minus of minus 1. So that is equal to 7I. So the point over here is whenever there is a single I or minus I in the denominator, multiply and divide with the I term in the numerator as well as denominator. Multiply with the numerator as well as denominator. Okay. Now the next thing is if something like this is there, 2 plus 3I upon 7 minus I is there. Okay, now there is no single I. There is no single I. So this time we are having 7 minus I. It's a proper format of a complex number. So the point is whenever we are having a proper format of a complex number, multiply and divide with the conjugate of the denominator. Multiply and divide with the conjugate of the denominator. Okay. So earlier two cases were different. This is different. Whenever we have a proper format of a complex number, multiply and divide with the conjugate of the denominator. Fine. So we'll go to exercise 9B. Question number 1, sub question 1. If you read the problem, R is the first complex number. R is equal to 3 plus 7I. S is the second complex number, that is equal to I. So R plus S is equal to 3 plus 7I plus S. S is I. So when you open the bracket, this will be 3 plus 7I plus I. So this will be 3 plus 8I. R minus S will be 3 plus 7I minus I. Open the bracket. So this will be 3 plus 6I. Okay. They're also asking R into S. They're also asking R into S. So we'll just calculate that R into S. R into S is equal to 3 plus 7I into I. 3 into I is 3I plus 7I square. So 3I plus 7 into minus 1. I square is minus 1. So 3I plus, 3I minus 7. So this gives me minus 7 plus 3I. Okay. Minus 7 plus 3I. R into S. Okay. And then R upon S. R upon S will be 3 plus 7I upon I. Now we have a single I in the denominator. So multiply and divide with I. So 3I plus 7I square upon I square. So put I square as minus 1. So 3I minus 1 into 7 is 7. Okay. I've taken I square as minus 1. So minus 7 into 7 is minus 7 upon minus 1. Okay. Now just write in proper format. Real part first and then the imaginary part. Minus 7 plus 3I upon minus 1. Minus 7 upon minus 1. 3I upon minus 1. 7 minus 3I. Fine. Okay. So that was the first. Let's go to the next problem. Question number 2. R is equal to minus I. S is equal to 5 plus 2I. So R plus S, that is minus I plus 5 plus 2I. Just open the brackets. So minus I plus 2I will be minus I plus 5. So this will be 5 minus I. And R minus S. Minus I minus 5 plus 2I. Minus I minus 5 minus 2I. So this will be minus 5 minus 3I. So minus I and minus 2I is minus 3I. Okay. Write always in the format of a complex number, a plus bi format. Okay. Next one. Okay, sorry, r into s, that is equal to minus I into 5 plus 2i minus 5i minus 2i square minus 5i minus 2 into I square is minus 1 minus 5 plus 2, which is equal to 2 minus 5i. Okay, and r upon s is equal to minus I upon 5 plus 2i. Okay, so we have a proper format of a complex number. So multiply and divide with the conjugate of the denominator. Multiply and divide with the conjugate of the denominator. Okay, the conjugate of the denominator is 5 minus 2i. Okay, so this will be equal to minus 5i plus 2i square. I'm multiplying minus I to both the terms over here upon a square minus b square. Okay, so a is 5 and b is 2i. So minus 5 plus 2i square. I square is minus 1 and this is 25 minus 4i square. Okay, so minus 5i minus 2. 25 I square is minus 1, minus 1 into minus 4 is plus 4. So minus 2 minus 5i upon 29. So this will be minus 2 by 29 minus 5 by 29. I hope you got the point over here. Okay, so the real part is minus 2 by 29. Imaginary part is minus 5 by 29. Always write in the complex number format. Okay, so sub question 2, 3 and 4 I am just giving you for self study. You can manage those things. First one is R, second one is S, then all four algebraic operations you have to do: addition, subtraction, multiplication and division. Okay, so let us go to the second problem now. Second problem, we are supposed to find out the values of x and y. So the first sub question is x plus yi, okay, plus 3 minus 2i equal to 1 plus 4i. Okay, so x plus yi equal to 1 plus 4i minus 3 plus 2i. I took this entire term on the right hand side. So x plus y is equal to 1 plus 4i minus 3 plus 2i. So 1 minus 3 is minus 2 and 4i plus 2i is 6i. Now the left hand side is a complex number format, a plus bi or x plus yi. Right hand side is also a complex number format. So there is equal to in between. So we can compare by comparing real and imaginary parts. X equal to minus 2 and y equal to 6. X equal to y minus 2 and y equal to 6. Okay. Second sub question, you can do it for self study. I'll take you to the third sub question. It's very simple basically. Okay. 2x plus yi is equal to 1 plus 2 plus 3i. So 2x plus yi is equal to 1 plus 2 plus 3i. 2x plus yi is equal to 3 plus 3i. So by comparing, 2x is equal to 3 and y is equal to 3. See, left hand side it is a plus bi format, right hand side a plus bi format, equal to in between. So compare the real part. Real part is 2x, that is equal to 3. So x is equal to 3 by 2. Imaginary part is y equal to 3. Fine. And the fourth sub question also I can give you for your own practice. Okay, so let us proceed with the next problem. That is question number 3. Determine the conjugate and the reciprocal of each of the following complex number. So the first complex number is z. Z is equal to I. So conjugate z bar is equal to minus I. Only the sign of the imaginary part changes. And reciprocal 1 upon z is 1 upon I. So how to solve 1 upon I? Multiply and divide with I. Okay, it's a single I in the denominator. I upon I square, I upon minus 1. So this is minus I. So in this case, the conjugate as well as reciprocal is having the same answer. Second, z is equal to I cube. I cube is equal to I square into I minus 1 into I, which is minus I. So z bar is equal to plus I, and 1 upon z is equal to 1 upon minus I. I won't solve this further. I'll just give you the hint. Just multiply and divide with I and check the answer. Fine. Third one, third sub question. Z is equal to 3 minus I. So z bar is equal to 3 plus I. Okay. 1 upon z is equal to 1 upon 3 minus I. So it's a proper format of a complex number in the denominator. So multiply and divide with the conjugate of the denominator. Okay. Multiply and divide with 3 plus I. Fine. So this you can solve on your own because you know the technique how to solve. Next one, question number 4. Z is equal to root of minus 1 minus 3. So this is equal to I minus 3, which is minus 3 plus I. So this is a proper format of a complex number. Okay. This is Z. So Z bar is equal to minus 3I and reciprocal. Okay. Is 1 upon minus 3I. Multiply and divide with the conjugate of the denominator. Okay. So down it will be a plus b, a minus b. That is a square minus b square, where a is minus 3 and b is 3I. Okay. Multiply and divide with the conjugate of the denominator. Fine. That was your question number 4. Let us go ahead with question number 5. Z is equal to root of minus 9 minus 1. Now root of minus 9 can be written as 9 into minus 1. So root 9 into root minus 1. 3 into I, which is 3I. So Z is equal to 3I minus 1. Z is equal to minus 1 plus 3I. So Z bar is equal to minus 1 minus 3I, and 1 upon Z is equal to 1 upon minus 1 plus 3I. So to solve this, we have to multiply and divide with the conjugate of the denominator and solve further. Okay, you have to solve this further. So this was question number 3. Let me take you to question number 4. It's a simple simplification. First problem, Z is equal to 3 minus 7I the whole square. So a square plus b square minus 2ab. 2 into 3 is 6, 6, 7 is 42. I square is minus 1, so this will be minus 49. And this is going to be minus 40, minus 42I. A plus bi format. Okay, second sub question. Minus 1 by 2 minus root 3 by 2 I square. Okay, so minus half I'm taking common. So 1 plus root 3I. Within the round bracket, I'm taking half common. So it will be minus half is going outside. So within the bracket, we'll have 1 plus root 3I. Fine. And a common square. Okay. Now minus half square will be 1 by 4. And this square you have to expand. A plus b the whole square. So a square plus b square. Square of this is 3I square plus 2ab. Plus 2ab. Now I square is minus 1. So this is going to be minus 3. So 1 by 4, 1 minus 3I plus 2 root 3I. Plus 2 root 3I. Okay. This I have written as minus 3. Fine. So one second. Yeah. So this is going to be 1 upon 4 minus 2 plus 2 root 3I. So 1 upon 4 into 2 is half. So minus half plus half into 2 root 3i. So this is the real part and this is the imaginary part. Imaginary part is root 3 by 2. Okay. Next one, question number 3. I mean sub question 3 of question number 4. Z is equal to 9 plus 4i. Okay. And 3 by 2 minus I. And this is 9 minus 4i. So we are going to club these two terms. 9 square minus 4i the whole square. And this term we are going to take LCM. 3 minus 2i upon 2. 3 minus 2i upon 2. 81 minus 16i square. Okay. 3 minus 2i upon 2. I square is minus 1. So minus minus will be plus. So 81 plus 16 upon 2. 2 minus 3i. So 97 by 2. 2 minus 3i. Now what you have to do? You have to multiply 97 by 2 with both the terms within the round bracket to get the real part and imaginary part. So just multiply this with both the terms. Okay. That much you can do. Should not be an issue. Okay. Let's go to question number 5. Sub question 1. X plus y upon I plus x minus y plus 4 is equal to 0. Okay. So what we can do is we'll take the LCM. X plus y plus xi minus yi plus 4i upon I is equal to 0. So the green colored terms are real terms. So take it together. So this is x plus y plus, always put a bracket and write I. Okay. This we are doing for the imaginary terms. The blue colored terms are imaginary terms. Okay. And at the same time, what I'm doing is I'm sending this I to 0. So this is going to be 0. Yeah. And in the bracket, it will be x minus y plus 4 equal to 0. I into 0 is 0. Okay. So x plus y plus x minus y plus 4i equal to right hand side also write complex number format. So 0 can be expressed in the complex number format as 0 plus 0i. Okay. So now compare the real and imaginary parts. By comparing the real and imaginary parts, the real part is x plus y. So x plus y equal to 0. Imaginary part is x minus y plus 4. So x minus y plus 4 is equal to 0. Okay. Imaginary part on both the sides. Now solve these two equations simultaneously. You'll get the value of x and y. Fine. Second sub question. Second sub question. Minus x plus 3y I plus 2x minus 1 minus y plus 1 is equal to 8 upon I. So minus of 3x plus yi plus 3yi, okay, plus 2x minus 1 plus 1 minus y plus 1, multiply and divide with I. Now see, this is the real part. There is no I over here. So I'll express it first. I'll write it first. 2x minus y plus 1 minus x plus 3yi is equal to 8i upon I square. Now this is I square, which is minus 1. So this is minus 8i. So 2x minus y plus 1 minus x plus 3yi is equal to 0 minus 8i. So if you take a look at this, 2x minus y plus 1 is equal to 0. Okay. And minus x plus 3y is equal to minus 8. So by comparing the real and imaginary parts, 2x minus y plus 1 equal to 0. So 2x minus y is equal to minus 1. This is the first equation. And the imaginary parts, minus x plus 3y is equal to minus 8. So minus of x plus 3y equal to minus 8. Minus minus is getting cancelled. So x plus 3y equal to 8. Solve this two simultaneously. You'll get your desired answer. Okay. That was question number 2. I mean sub question 2. Let's go to question number 3. Question number 5. Sub question 3. X minus yi is equal to 2 plus I upon 1 plus I. Okay. So x minus y multiply and divide with the conjugate of the denominator 1 minus I on the right hand side. X minus yi is equal to 2 into 1 minus I plus I into 1 minus I. Down it will be a square minus b square. Okay. Down it will be a square minus b. So x minus yi is equal to 2 minus 2i plus I minus I square. 2 minus 2i plus I minus I square, and down it will be 1 minus I square. Okay, now I square is minus 1. So minus minus in numerator as well as denominator will be plus 1. So I square minus 1 into this minus is plus, minus 1 into this minus is plus. So x minus yi is equal to 2 minus I plus 1 upon 2. So 3 minus I upon 2. 3 by 2 minus I by 2. So the real part is 3 by 2 and the imaginary part, that is the complex part, is minus 1 by 2. Okay, I hope you understood this. Okay, so question number 4. X plus, sorry, 3 minus 4i into x plus yi is equal to 1 plus 0i, right? So what I'll do is 1 plus 0i is technically 1. Okay, so x plus yi, I'll cross multiply 3 minus 4i. Okay, so x plus yi is equal to multiply and divide with the conjugate of the denominator. Multiply and divide with the conjugate of the denominator. Fine. So x plus yi equal to 3 plus 4i in the numerator. Okay. 3 square minus 4i the whole square. 3 square minus 4i the whole square. Okay. So x plus yi 3 plus 4i, 9 minus 16i square, x plus yi 3 plus 4i, 9 plus 16, I square is minus 1, minus 1 into 16 is minus 16, plus minus 16 into minus 1 is plus 16, 3 plus 4i upon 25, so 3 by 25 plus 4 by 25i. So x is equal to 3 by 25, y is equal to 4 by 25. Okay, that is how we are supposed to solve this particular problem, by comparing the real and imaginary parts. Okay, let us go to the fifth problem. Question number 5. X minus yi 2 plus 3i, x minus 2i 1 minus I. Okay, so what we'll do is we'll multiple ways to solve this particular problem. Fine, so I'll just multiply these two terms. 2x, 1 second, x into 2 plus 3i minus yi into 2 plus 3i is equal to, right hand side I'll just take the conjugate of the denominator. It's division with the proper format of a complex number. So 2x plus 3xi minus 2yi minus 3yi square equal to x into 1 plus I minus 2i into 1 plus I upon a square minus b square, a square minus b square. Okay, so right hand side, these two terms will be together because they have I with it, and I square is minus 1, so this is going to be plus 3y. Okay, so 2x plus 3xi minus 2yi, 3xi minus 2yi plus 3y equal to, right hand side, see, 1 square is 1 minus I square. So this is 1 minus I square. At the top in the numerator, we are having x plus xi minus 2i minus 2i square. X plus xi minus 2i minus 2i square. Now I square being minus 1, there will be the sign change. And here 2x and 3y I will club together. Okay. 2x and 3y I will club together. Okay. Because those are real parts. There is no I along with it. So it will be x plus xi minus 2i plus 2, 1 plus 1, because I square will be minus 1. So 2x plus 3y plus 3x minus 2y into y equal to, I'll group this and this term, x plus 2 plus bracket into y upon 2. So I have taken out common, so within the bracket we'll get x minus 2. Now multiply this 2 on the left hand side, so it will be multiplied to the real part as well as imaginary part. So 2 into 2x plus 3y plus 2 into 3x minus 2y equal to x plus 2 plus x minus 2y. Okay, so this will be equated to x plus 2. So 4x plus 6y equal to x plus 2. So 4x minus x is 3x plus 6y is equal to 2. Fine. And then imaginary part will be multiplied, will be equated to the imaginary part on the right hand side. So 6x minus 4y is equal to x minus 2. So 6x minus x is 5x minus 4y is equal to minus 2. Now these two equations you have to solve simultaneously and get the answer. Okay, that I leave it up to you. Okay, so let us do one more problem, that is question number 6. X raised to 4 plus 2xi minus 3x square plus yi equal to 3 minus 5y plus 1 plus 2yi. So x raised to 4, I'll open the bracket, 2xi minus 3x square minus yi equal to 3 minus yi plus 1 plus 2yi. Now x raised to 4 minus 3x square will be clubbed together plus bracket into I. So the bracket will have 2x minus y. I took I common. Now 3 and 1 will be clubbed together. So this will be 4. This will be 4 plus bracket into I. So minus 5 plus 2y. Minus 5 plus 2y. So left hand side also we are having complex number format, a plus bi. Right hand side also we are having complex number format, a plus bi format. So we have to equate and get the answer, right? So x raised to 4 minus 3x square equal to 4. I'm equating the real part on both the sides. Okay. So first we'll simplify this. x square the whole square minus 3x square minus 4 is equal to 0. Okay, let x square be m. So m square minus 4m plus m minus 4 equal to 0. M minus 4 plus 1, m minus 4 equal to 0. So m plus 1, m minus 4 equal to 0. So m equal to minus 1 or m equal to 4. X square equal to minus 1 or x square equal to 4. So x is equal to root of minus 1. Since this is complex, we will discard this particular case. X and y are supposed to be real values. It's given in the question. Or x is equal to plus minus 2. So there are two different values of x, right? Now we will compare the imaginary parts. If you take a look at the imaginary part, 2x minus y is equal to minus 5 plus 2y. 2x minus y is equal to minus 5 plus 2y. I hope this is right. 2x minus y is equal to minus 5 plus 2y. Okay, great. So 2x is equal to minus 5 plus 3y. So minus y, set it on the right hand side. Okay. So here you have to put x as 2 and x as minus 2. Respectively, you'll get the value of y. When x is 2, y will be something. When x is minus 2, y will be some other value. So that part I leave it up to you. So this is the end of the section number 1, where we have completed 5 different problems of exercise 9B. Thank you.